This is lesson 8.5b, simplifying complex fractions. So a complex fraction is when you have a fraction within a fraction. So in the numerator, there's a fraction. In the denominator, there's a fraction. Oftentimes, if you have just one fraction numerator denominator, you can go, okay, instead of dividing by a fraction, I'm going to multiply by its reciprocal. So you just take the reciprocal of that one and multiply. So it'd be 2 over x is the numerator times the reciprocal of the denominator would be y over 3. And so you get 2y over 3x. And that's simplified. Now this is not a complex fraction. This is just a fraction. Has a numerator denominator, doesn't have a fraction inside of the numerator or the denominator. A little tougher with this one, but let's see what happens. So it's just a fraction divided by a fraction. So let's just take the numerator. And we're going to multiply by the reciprocal of the denominator. So this would be x minus 1 over 5. And so we get 3 times x minus 1 over 5 times x plus 1. I was hoping something might cancel there, but it doesn't look like it. But at least now we simplified it down to just a regular old fraction. It's not a complex fraction. Okay, see what happens here. Very similar. We're just kind of going a step at a time, just a touch harder each time. So 4 over, instead of this, I'm going to go ahead and just factor that because I see the factoring x plus 1, x minus 1. Times the reciprocal of this guy, right? We're flipping that. So it's going to be x plus 1 over 3. And now because we have multiplication, because these are all being multiplied, I am allowed to cancel that. So that actually is just fine. So we get 4 in the numerator and 3 times x minus 1 in the denominator, x minus 1. And that's about as simple as you can go there. Okay, so got a fraction divided by a fraction. So again, we're going to take whatever fraction is in the numerator, which is x plus 3. Always put parentheses around those, x minus 3, just get in that habit. Now the reciprocal of the denominator, I'm going to go ahead and factor both of those. So like in the denominator now, it's going to be the factoring of this numerator, which is x plus 3 times x minus 3. And I also see some factoring can be done with this one. When I move that up to the denominator, I'm going to take out the GCF of 3, so 3 times x minus 3. And see if anything cancels. I see that cancels. I see that cancels, and you get, this is going to equal 3 over x minus 3. Again, write the parentheses, that'll prevent you maybe from butchering it, which is a good thing. Okay, so this one, now we have a choice to make. There's kind of two ways to solve this. You can't just flip it like we did the last one because it's more complicated in the denominator and numerator. It's not just one fraction. It's an integer plus a fraction. It's integer minus a fraction here. So let's do this first. So let's try to push together the numerator and push together the denominator into one fraction so we can do what we did before. So this one is missing an x here. This one is also missing an x. So if I do this, I'm just going to go a step at a time. So in the numerator, it's going to be x over x plus 2 over x. That's going to add together. That's going to be x plus 2 quantity over x. And the denominator is going to be 4x over 4x minus, sorry, that's a minus there. Minus 6 over x. So that's going to be 4x minus 6 over x. Okay, I'm going to divide. Now I can use the same strategy we used before, which is to say, okay, we're going to do the numerator, which is x plus 2, divided by x. And we're going to flip the denominator, right? So now x is on top, and I'm going to simplify that by saying 2 times 2x minus 3. Just in case something cancels here. These x's certainly cancel, and you're left with x plus 2 over 2 times 2x minus 3. And this one, Well, let me show you the other way of doing that one. So going back to this one, so I'm going to take, I'm going to clone this and get a, so let's just move this down. So this is a different way of handling the same problem. So you might like this way. It's kind of similar to what we did in the last section, multiply the LCM. So I'm going to multiply the whole numerator and the whole denominator by the same thing. In this case, the LCM, which is x. So multiply the top by x and the bottom by, not x over x, just x. Because that's x over x, which is 1. So when I distribute this, I get, in the numerator, I get x plus 2x over x, which is x plus 2 in the numerator. Wow, that's pretty nice. In the denominator, I get, when they distribute, I get 4x minus 6x over x, which is 4x minus 6, or 2 times x, 2x. Do that again. 2 times 2x minus 3. And I think that's the same answer we got up there when we did it. Yeah, it's the same answer, isn't it? So it's a little bit faster. You can see that way it might be faster, multiplying by the LCM. I think it can be. So if you did that on this one, the LCM would be x minus 2 times x. The quantity x minus 2 times x. You can, you have a choice here as to, really, you could just multiply this one by x over x. So if you do that, in the denominator, you now have, this is going to be 2x over x plus 1 over x. So in the denominator, you have just one fraction. You have 2x plus 1 over x, which is actually not bad now because our numerators went 1 over x minus 2 to minus. And so now we can do our trick of 1 over x minus 2 times the reciprocal of that guy, which is x over 2x plus 1. Unfortunately, nothing cancels here. So you're just left with x over x minus 2 times 2x plus 1. But at least it's just, we got rid of the complex part of the fraction part here. If you want to do that one the other way, again, I'm kind of showing you both ways because you might like one way over another, and I don't really care which way you use. It's really fine either way. So using the LCM type method here, so you're going to multiply, I'm just give myself a little bit more room. So that's in parentheses, it's in parentheses essentially. So multiply top and bottom by the LCM, which is x times x minus 2, and x times x minus 2. So if I distribute that, watch what happens here. So this is going to be, the x minus 2 is just going to go away, right? You get x times 1, which is x. Well, it's pretty nice. This one, when you distribute to the 2, well, you just get 2x times x minus 2. That doesn't simplify, not yet. Plus, when I multiply by the second term, the x's go away, so I'm just left with x minus 2. So I'm going to simplify that denominator. This is going to be 2x squared minus 2x plus x is minus x minus 2. So I think that would be your answer, unless, let's just kind of see if this, let's try to guess and check that. I don't know if it factors or not, but it certainly could. So this would be x over, if it does factor, I know it's 2x and x. Then I'm trying to figure out, is it 2 and 1 or 1 and 2? So this would be 2 plus 2. No, that doesn't work. 1 plus 4. No, that doesn't work. It doesn't factor. So I'm pretty confident that's the best answer. Here again, like you can kind of bring these together. You have to multiply this one by x over x first. but that's not a bad way to go. So the numerator you'd have, we're getting used to this. So this would be 6x plus 2 over x. Denominator would be 1 over y. I'm going to simplify the numerator. It would be 3 times x plus 1. I'm sorry. Take the GCF out, which is not 3, it's 2. So it'd be 2 times x plus 1 times 3x plus 1 over x times the reciprocal of this guy. So that's going to be y over 1. So we get 2y times 3x plus 1 over x. The other way of doing this is to multiply top and bottom by xy. That'll make all the denominators go away as well. That's the lesson for today. Let me look back at this one. So just try this one. Product of the complex numbers, that and that. So when you FOIL that together, let's do that. So first times first would be negative 9i squared. Outside would be plus 12i. Inside would be minus 12i. It's kind of interesting. And last would be plus 16. So I squared is really negative 1 here. So that's positive 9. These go away. Plus 16, which is 25. You can also type that in your calculator. So your calculator can actually handle that. So you can do, I believe it can. Well, let's see. Well, let's just do that one by hand. I think it'd be good.